Hello, everybody. Hello, and welcome to the third episode of the Keep Coding podcast. I still can't believe I am here today with my guest, Mads Torgersen. I'm sure for many of you, Mads doesn't need any introductions, but I'm going to let you know that Mads is mostly known, obviously, for his work on Java generics, which was instrumental for Java. But obviously, I'm joking. He's the lead designer of C#, and that's why all of you know him. And I'm so happy today to have these 2 hours with him to ask so many questions. And I hope I don't go into more than those initial 2 hours. So Mads, thank you so much for being here.
Well, thanks for having me here. I'm very excited as well. Sounds like we'll be busy.
Yeah. So I first saw you in person. Well, I think actually it was in the last MVP summit in 2019, I want to say March, where you had a language discussion, sort of secret, those MVP secret presentations where you talked about C#9 with the title 9 is fine. And now here we are with C#11 and 12 coming obviously next year. And then I saw you again in NDC Copenhagen this year, where you started one of your talks with like 5 minutes, or actually it was before the talk, 5 minutes of Danish. And I'm like, am I having a stroke or is he just speaking another language? It looks like such a hard language to pronounce and to try to enunciate.
It's actually much easier to pronounce than it is to understand. There are scientific studies now that show that Danish is almost uniquely hard to learn to understand. Spoken Danish has more vowels than almost any other language, and fewer consonants. It's sort of just like
it sounded like it. And I'm Greek, and people say Greek is hard, but truth to be told, other than the fact that the language is different, you have to write in Greek. It's not so hard to learn. There's no tricks in English, many times I see words like thought or though, and I just cannot understand how these things are pronounced differently, even though they're written the same. We don't really have that in Greek.
Right. Yeah. Danish and English are sort of similar in that way, that the spelling bears only a loose resemblance to pronunciation.
Yeah. So I recently heard this fact, and I want to check if it's actually true, that you are the only person working on C# full time in Microsoft. Is that true? Technically.
No, not the only person working on C#. No. But I am. I think what I've said is that on the C# language design team, I'm the only one who's there because that's my job.
Right.
That's even exaggerating a little bit, because everybody there gets recognized for their time on the C# language design team. And for some people, like Kathleen, who is PM for the .NET languages, it's also her job to be there, right? She couldn't not be there. But other people, like many folks from the compiler team, ASP.NET team, IDE team, and so on, they're there because of their passion for C#, and of course their insanely good skills and wonderful personalities, taking time out of the day job essentially to come and help make C# better. So it's in that context that I've said I'm the only one who's sort of like that, where being there is my primary responsibility that I'm getting paid for.
So if someone wanted to join the C# team, is there such a thing, or you'd have to work on something around C# and then you just go to the meeting, so you try to help improve it?
Yeah, there's the C# compiler team, for instance, or C# and VB compiler team, and a few other things now that they work on. There's an IDE team that does the integration of C# into the Visual Studio and Visual Studio Code experiences and so on. So there are many like C# teams. Of course, there's the .NET team, which is much larger, and most of what the .NET team does is consumed through C# or one of the other .NET languages. So it's all a matter of how you define it. on the extreme end, I'm the C# team, and on the other extreme end, there's like, I don't know, hundreds of people on it. So it's all down to definition.
Okay, I see. Okay, well, I'm gonna go straight into the first thing, which is the C#11 release, because a lot of things happened even before it was released, and I want to touch on all of those things. I'm going to start with the first thing that happened, which, maybe we're going into the controversial stuff straight away, but
do it.
That's good for your attention. The bang bang operator, the way you introduced this feature very early in the preview, and I think intentionally, if anything, to collect feedback and take the decision you took to pull it out. How in retrospect, how do you feel about that?
I actually feel great.
So you agree with the removal?
Yeah. I mean, I was in favor of the feature, but so as a stakeholder in C#, I would have wanted it in there. But that goes for so many features that we don't do. That's why we have a team and not just me. Because what I feel great about is that we made the decision diligently. It's really hard when you have something that a lot of people are passionate about, but also a lot of people are passionate on the other side. Like what do you do? You kind of have to look at the problem from many different angles, try to see through the passions and try to think ahead for the long term and so on. And in the end, there are so many features we could add to C#, great features too, that we won't ever get to add them all. And luckily, because C# would be overloaded then. And in the end, if you have a feature that sort of consistently comes down to 60% love it, 40% don't, that's just not enough to really justify it. And in the end, it was just it was better not to. And that doesn't mean C# will never have that feature or something else with a better syntax that somebody finally comes up with, or it could come back someday. Nothing is, if something is in C#, it's in there forever. But if it's not in C#, it's not outside forever. It could come back or in some way, shape, or form. But this form at this time was not the right thing to do. And because so many people were so passionate about it, I feel really good about the amount of diligence we put into it, including releasing a prototype, having people try it out in their own code bases and so on.
So do you think that is, I mean, I guess the answer is no, but now that C# is more open than ever, and .NET as well, getting that feedback early, especially on things you assume they're going to be controversial, because I think you assumed that this would be the case. It's a bit of an interesting change. Makes the language more community focused, even if the community itself is not writing the compiler. By voicing no or yes, they have an input.
Yeah, I think at the end of the day, I mean, it's not a democracy, and there's not it's not like in the end, the design decisions are not made by the community. There is a language design team, and also there are resource owners inside of Microsoft owning at least still the majority of resources that go into developing C#. But at the end of the day, what we're interested in is making a C# that people really love, that really makes everyone's day better. And so having that continuous broad feedback loop with the people who will eventually, suffer the consequences, is good for everyone. And it's actually a lot of fun. I started 17 years ago, more than 17 years ago, working on the C# team. And back then, everything was secret until the big reveal. And I didn't actually enjoy that. It was a necessity. And we tried to make up for it as best we could with MVPs to some degree, with, having a design team that was diverse and all that. But at the end of the day, that is, that is way too nerve-wracking, and the risk is way too high of doing something that falls flat. So
Yeah.
I like this much better.
So how do you think would it go if something like dynamic came in today? If it never existed in C# and there was a proposal for exactly how it is implemented now, and it tried to go in C#?
That's a good question. I think that it depends on the context. Dynamic was created in a context where we thought very seriously that .NET was going to have dynamic languages as well, that there were going to be Python and Ruby implementations deeply interoperating with the other .NET languages, C# and VB, and the emerging F# at the time. So if we had that belief today, then I think we would have looked just as seriously at a feature like that. Now, so there's both the would we have done the feature or not? I actually think that in many ways the feature design was a good realization of what we thought was going to be important for C#. So it's more the hindsight than the closeness in this case. Now, as for the details of the feature, it's quite possible that some aspects of it make it very performance heavy. It's quite possible that those would have been different if we had had more community input. And also another form of hindsight, dynamic, I usually joke that dynamic came out, the day people started being interested in smartphones and devices and the cloud, right? For the first several years I was on the C# team, it was all about Windows and on desktops and laptops, and those machines were getting bigger, following Moore's law year after year. And so if something was a little slow or if something was a resource hog today, as long as we left it alone and didn't bloat it some more, it would be fine next year or the year after, right? That was kind of the way the world worked.
Yeah.
For us at least. So dynamic was the most resource heavy feature that we've ever added, I think, to C#. And in hindsight, we should probably have thought more about that part.
It looks like that used to be more of a trend at the time in the .NET languages. I remember, and I've never written actually Visual Basic, but from what I understand, Visual Basic has like first-party XML support or something along those lines, because XML was so prevalent. So yeah. I can imagine if JSON at the time was something like that, then Visual Basic or C# maybe would have that as a first-party feature. And now it looks like you're trying to be way more agnostic about what this thing will return. Like I remember when Newtonsoft .json, the package, well, you hired the creator, and then you create the system.text.json in .NET. That was big because it's like, oh, it's under system.text now. They believe in it, even though we had JSON be the standard for a long time. So it looks like now you're trying to validate that the thing will stick around, and then you dive into it. Same with how the whole cloud native initiative around .NET is now going. You waited to see that, yes, this is the thing, and then you're focusing on it. So I personally prefer that approach.
I think that it's important to be prudent with those things. And I think there are different layers of the stack that have different kind of bars for what it takes to add something. The .NET Core libraries, yes, they need to sort of, in order to bless something and say, yes, we embrace and support this technology, it needs to have a certain perceived staying power. And of course, to take it into the language is a much, much higher bar still. I don't think that we would even consider adding JSON literals, for instance, to C#. Now, that was actually, I think that was a bit of a nuance difference there with VB, where VB was more willing to embrace more things directly in the language in the service of being more of those things being more accessible. Like having, the XML literals feature is beautiful in Visual Basic. It is, I mean, it's amazing the way the holes are made and the way it's just like, wow.
Yeah.
But it locks it to XML, right? So it's a different trade-off.
Yeah.
And different languages have different trade-offs. By now, C# being more than 20 years old, we know that we're in it for the long haul, and we can't tie ourselves too hard to. We try to avoid tying ourselves too hard to a technology that may not have at least the staying power that C# itself has.
And don't really need to, because if I use that as an example, now we have raw string literals, and we also have the system syntax attribute. So it's up to the IDE to even highlight you JSON if you want to have a JSON blob in there and check if the syntax is right, which sort of solves the problem. Now, I know we're talking about C# 11, but I want to take a bit of a step back and then maybe a step forward and talk about C# 10 and .NET 6, because there was something very interesting that happened. Obviously, there's a very clear initiative that the whole .NET team, and I guess the C# as well, wants to make C# more attractive and more accessible for everyone, even for enterprise commands, but also more junior developers. And we saw this push both from the .NET and the ASP.NET Core team to make minimal APIs a possibility and have this very 3 lines of code thing that just works, but that needed C# changes. So they sort of pushed you, from my perspective, to have type inference on lambdas, which technically was possible because I know that this thing accepts a string and returns a string, but the compiler acts like, oh, I don't know what to do with this. So what do you think about that initiative? And do you think this will happen again soon? I know native AOT is a thing now that's being pushed, so I want to know your thoughts on that.
Yeah, I think it'll happen again and again and again. I'm very proud about that collaboration. It's a great example of, I think we get an excellent trade-off here where, as I said, there are many features we could add to C#. And as for, type inference for lambdas, it seems like we could have done that from the beginning. Again, Visual Basic did it from the beginning. The thing that made us not do it is that we didn't have clear important scenarios to drive the design, right? You can't just add a language feature into the void. You need to have these very clear scenarios not just motivating it, but that's one thing. Like, okay, this rises above the cut line now. This is one of the important features for us to focus on because it's important to another team and their experience, but also it helps guide the design. Because there are many, many details at the end of the day that should we go this way or the other way? If it's all like, man, we don't know, let's just pick something. That's not a good place to be, because then when the important scenarios come around, it invariably turns out we did the wrong thing.
Yeah.
So it gives us a concrete, or preferably a set of concrete scenarios to design into that help guide the details of the design, even as it also helps justify doing it in the first place. Now, what we have to be careful not to do is to make the feature over-specific to just that design or just that scenario, right? So, so it's better if you have a couple of scenarios, or at least can envision some. But I think, generally we've been quite good at not making features too specific in C#. They tend to be general purpose language features for the most part. So yeah, that's the balance we're striking, and having these cross layer initiatives in the .NET stack is actually, first of all, it's fun, and I think it has really good outcomes. It's also one of the strengths of .NET compared to some other stacks is that we have coordination between all the layers, the runtime, the core libraries, the language, a lot of the IDE experience. At least we don't sort of own all the C# IDE experience in the world, but we definitely have more than one IDE and can think that in to the language design as well. So we get to align and get to learn from each other. We get to do things in the right place in the stack where it belongs, as opposed to, bending ourselves over backwards to do something in the wrong place because that's the place we control. And that's really, especially with since the turn to .NET Core, that has become I think that has really come to fruition, where we are able to collaborate across all the layers to do the right things in the right places more than ever. And that is, yeah, super fulfilling.
Do you think you're now more empowered than ever because now you can touch the CLR, from what I understand, at least more than you would any other time. And we clearly saw that with generic math, which I have a bit of a problem with the name of the feature, because to me it is named after a use case. Like I will never call it for generic math, but you use it for generic math in .NET. I would use it, for example, to structure my minimal APIs and define and probably a static abstract member on an interface for that. How do you feel that finally that feature is shipped, which has been in preview for quite some time? And do you think now that you flexed that muscle, we're going to see more of those? And if yes, what do you think is going to be the next feature that requires such a change?
Yeah, I mean, first of all, we don't actually, I mean, there's a theme called generic math that involves using this language feature, as well as having a bunch of .NET library efforts. The language feature is actually, we tend to refer to it as virtual static members and interfaces or something like that. So yeah, that's actually a good example of a general purpose language feature that is driven by an important scenario. And it's true that this is something that we can only do because we allow ourselves to evolve the runtime itself. Like, there are many kinds of expressiveness that we can't, we wouldn't have been able to do just in the compiler. And even when we did them, that probably wasn't the right place, but that was the place that we could control. Right? We were, with the old, what we call .NET Framework now, we were locked into to being a Windows component. We couldn't really require a certain runtime on the end user's machines. And so we were effectively prohibited from making expressiveness changes to the runtime. And having that freedom now has freed us up to do several features that rely on that. I think we'll continue to make use of that, while we also have to keep in mind just the cost of doing something in the runtime is high. First of all, we have like 3 separate runtime code bases or something like that. We have JIT and we have AOT. There's a whole downstream set of tools that operate over IL that have to kind of now understand new things that can crop up in IL. So there's a high cost to doing something in the runtime, but we've been leaning into it nevertheless, because that is the right thing to do, and it gives us a new level of potential new expressiveness that we couldn't have before.
If you could go back, which feature that you added purely on the compiler changes without asking the CLR would you revisit to make those changes? Obviously you won't, but if you could redesign it with CLR changes, which one would you?
I think some good candidates are lambdas, actually. The closures, the way that, so I don't know if everyone knows, but the way that like you have a lambda, it can access local variables from the enclosing method. Well, the runtime doesn't know anything about that kind of thing. So what we do instead is we generate a secret class. All those local variables are not local variables at the runtime level. They're fields in the secret class. And we rewrite the code according to this. And that means that not only are the seams that show, but also there's information the runtime doesn't have. So there are kinds of optimizations it can't do, for instance. I think if we could have, we would at least seriously have considered expressing this somehow directly in the runtime. And another big one for that is async. I think that is probably the most gnarly code transformation we do in the compiler, closely followed by iterators, where we completely turn source code on its head, right? It's or if you look at the generated code, it's very, very gnarly because we're building state machines.
Yeah.
So the fact that something, for instance, has a stack discipline, and when things are no longer necessary, all kinds of information that follows from program flow are lost at the time where they're lowered to where the IL can pick up. And if we had access to the full stack back then, again, it's very likely that we would have put at least some parts of this in the runtime.
Yeah, I was looking into this very recently because I made a video on the topic, and many people were surprised by how much code await async will actually generate. You can actually see those state machines. If you want, you can take the lowered code, copy it, and it works. There's nothing that is just purely like compiler specific, except for some attributes which you can remove. And it's very interesting that, and I don't know if many of our viewers know that on debug mode, the state machine is actually a class, but on release mode, it's a struct to try and optimize any allocations when possible. So, within the constraints, he still try to be clever and optimized, which I find very interesting on an investigation level.
It was incredibly fun to build this, and, very, very smart people like Stephen Tobe were deeply involved in like how exactly can we eke out as much performance as possible, and we've kept doing that. We have value task next to task, and we have all these things that we've done over time to make async as to get as much performance back as possible. But the core of the matter is, we kind of did it in the wrong place. It was the only choice we had at the time.
Yeah.
But wouldn't it have been great if we could have thought about this across all the layers at the same time?
Would you reconsider, given the same, free of constraints logic, nullable reference types? Because now it is something purely on the compiler level that doesn't really feed into the runtime. So you can still set those values to null and nothing will happen until you eventually just call it.
Yeah, I think, I don't think there's much about nullable reference types that would have been better done in the runtime. Like the runtime knows, allows null.
Yeah.
And so it's sort of doing most of the job there already. I think that the bigger sort of the impedance mismatch that that saddens me around nullable types is the difference between nullable value types and nullable reference types. All the subtle ways that they are different. I feel like if we had thought about nullability from scratch, and then we could have designed something that was closer to being truly orthogonal, right? There's value types and there's reference types, there's nullable and non-nullable, and it all, blends together perfectly. Like perfect orthogonality or close to that on that front would have been great. But that was not in the cards for nullable reference types, not just because reference types are different, but also because, we could have said, another approach would have been to say, well, nullable of T now works on reference types as well. And we could have made nullable value types work for reference types. But now nothing in the world would have worked with that, right? Now we introduce a new form of null, and every library would have to be rewritten to take that into account and so on. That was just not, given the code base already out there, that was just not even close to being an option. The only option to ever do something about nullable would be to fully recognize all the existing code and just give you better tools to understand where you had sort of null risk in your code. So it was the best we could do at the time, I think. And yet, if I were to ever start a new programming language, then, I definitely have a note to self, think about nullability from the start and built it in deeply and make it orthogonal.
Well, I'm gonna put a note on that because I wanna mix that then with another question I have because that's very interesting that you mentioned that. Um, but I wanna say something else as well, which is where is the field keyword?
Um, you mean why didn't it come out?
Yeah,
That is actually that touches on another difficult aspect of C# and of every 20-year-old programming language, which is the field keyword is a simple feature. At the core, it's super simple. It's just that inside of for those out there who haven't seen it and been disappointed by it not being there yet, inside of a property accessor, you can use the keyword field, and that references the underlying field that is generated for you, because if it wasn't already an auto property, it will be, if
yeah,
you mention the field keyword. And so it's a way to have your cake and eat it too with auto properties. You can have you can put some custom logic in one or both of your accessors, but still have the compiler generate the underlying field for you. Simple little feature. Think of the field keyword a bit like value. It's just a named variable in that's only in scope in your accessor. However, it's a breaking change, right? Because you might already have say a field called field, lowercase field, and if we just add this feature the natural way, then it breaks some code. Probably a very small percentage of all the code in the world, but that's a lot of code in the world. So what can you do? What we've done so far with this kind of situation is to say, well, too bad, we have to come up with a more gnarly feature design that looks. So what we would essentially do is we would look for anything else called field in scope, and then we would take that first, and only if there wasn't anything found would we treat it as a keyword. Now it's not breaking anymore, but now it's super odd, right? And
yeah,
now your semantics are unpredictable, and we want to try to avoid that because we've done it before and it's not good. We did it with var, and it was less of a problem because not many people have types called lowercase var, or they didn't until they realized that they could block the feature by declaring a type called lowercase var, and then we would pick that instead of the keyword var, right? So making it not a proper keyword introduced gnarliness to the language that was purely for backcompat reasons.
yeah,
Quite esoteric backcompat reasons. But much, much worse was the discard feature that is, I love discards. I'm so happy we have them in C#, but they're represented by underscore, and underscore is also a valid identifier in C#. And so all the places where you declare something called underscore using existing syntax that was already there in C#, it has to continue to be an identifier. But in all the new places, like the outvars and the patterns and all the new places you can declare variables, we're free to make it a discard. And so depending on which syntax you use for your declaration, it's either a discard or a variable. And that's just like, people come to the language and look at this, and that boggles their minds. Like, who would ever come up with a design like this? And we're like, yeah, but otherwise we would break those people. And this is something that we need to try to come to terms with somehow. I think this is a discussion that I think the time is ripe for us to start having. Is there a way that we can move the setting a little bit on how we deal with backwards compatibility, so maybe we could have some very limited breaking changes that we'd have to be super judicious about, and that then come with some excellent tooling to help people essentially guard their code against this new feature and say, take just a fixer, right? Run it in Visual Studio or the SDK and say, take all the code that would be broken by this new feature and just fix it so that it's no longer broken. Just say this.field instead of field,
Yeah.
Just change the underscore to being some other variable name, _1. And then, people can harden their code, and then they can upgrade the, without any loss of semantics. Then they can upgrade without any worries to the next version. And the new feature has the nice design that's easy to explain, and that doesn't create these, moments of complete confusion. Like, what were the compiler people thinking?
Yeah.
And the difficulty is to, we kind of have to come up with an experience that covers enough people and kind of mitigates the concern that, what if I forget to, or what if I didn't know to fix my code, to harden my code first, or what is the story that makes people not accidentally fall into these breaks anyway? And can we help them if they do? So it's so many things have to be thought through for this to kind of become a good thing for us to do. But and it remains a possibility that it's too risky. But I think that if you look at other programming languages, there are other ones that are more they're a bit more lenient about breaking changes, that give people tools, even probably tools that are less reliable than what our standard is, and they still get away with it, and people are still happy. People are happier getting clean new features that work predictably than being protected against rare breaking changes in that way, like by the language never changing its semantics on anything. So it's a long story about it. We have to square that circle in order to put the field keyword in the right way.
Yeah, I see what you mean. So a bit of context, my main language is C# and .NET, but I started with Java actually, and I'm still using Java because I think it's a okay language. It has problems, but and I also write Kotlin. I like that language as well, heavily inspired by C# as well. And Java, actually, I can't remember if it was Java 9 or 11, they introduced the var keyword very late into the language compared to C#. Are you looking into how other languages like Java are introducing such breaking change? Because technically for Java, it's also breaking change. And how they are dealing with it.
Yeah, we are. And that is a good example. If I recall correctly, in Java, the way that there are kind of two kinds of breaking changes you can do with this kind of thing. The better one is that you outright break the code where it starts giving you errors that it used to compile and now it doesn't. That's great, because now you get poked to fix it up and get it running again. The more insidious ones are where you change the meaning of existing code, but it still runs. It just does something different. Like the field keyword is a big candidate for that kind of thing, because if you think about it, lowercase field as a variable name would be common to use as the explicit backing variable for uppercase field, the property, right? But other members, so if now field inside of the property implementation starts meaning a generated underlying field, great, that works the same for that property. But other members might be using the variable, and so all of a sudden there's subtle bugs that come from that variable not being updated by the property anymore. So these insidious, like silent breaking changes, they're the ones you want to try to avoid. And so I think what Java did for var, for instance, is to introduce kind of like a cool-off period of a few releases where var was no longer allowed as a variable name. So everyone who had it, hopefully, people would land on one of those versions on their journey through time. They would get an error, they would fix it up and use some other name instead of var. And by the time they actually reintroduce it as a keyword, people will have fixed their thing. And that kind of works if, you have to strike a balance about the cool-off period and so on. But it also means that the feature, the feature won't be there for a while. You got to go through purgatory and come out on the other side. And And so I would really like it if I like the idea, but I would like it if we could essentially have, sort of between between C sharp 11 and C sharp 12, we have C sharp 11.-1. That is C sharp 11 with all the things taken out of it that would be broken in C sharp 12, right? Or something like that. It would give you errors and everything, including what would have been silent breaks. And we make people go through that somehow and give them excellent fixtures and a fix everything button. And I don't think we should actually have an extra language version in between. It's sort of more like as a mental model. Yeah. If we could compress that waiting period to just being like a step that you go through and then you're done and then you can go to the new thing.
Yeah.
That is a model that we've been thinking about.
That is also because, again, I'm going to mention Java for multiple reasons, from inspiration for C# to how similar they are conceptually, from your work on Java as well, working on generics, which I don't know if many people know, but yes, even though they have their own problems with type erasure. I'm not going to go into that. I'm not going to show you my scars using Java, but Java releases features now mostly in preview, and they keep them in preview for 2 versions. And you can opt into the features. And for those of you who don't know, ever since Java 8, I think, so from 9 onwards, they release every 6 months a version, which is like 9, 10, 11, 12, but the LTS is every year or 2 years. I can't remember exactly. So technically, they release a 0.5 version every 6 months. Have you considered, obviously you did that with virtual static abstract members, maybe I added an extra word there, and also with, was generic attributes as well in preview, or was it pulled out and then added in the next version?
I mean, generally, so we also put features out in preview. We approach it a little differently. Essentially, the way we think of it, we have a whole year. We don't release every 6 months. And the way we think about it is that the period from and including typically with some exceptions, but generally the previous release and up until the next release is a time for us to introduce features in preview. We still have to get a little more systematic about it, but we've been working in that direction. And we were pretty systematic about it in C# 11, where we built the features during that release. And if there's a good reason to build them early in the release, we do that. And one of the good reasons could be like for the bang bang operator that we want to get feedback on them. Then we just put them out in whatever is the next release of the compiler that comes out. And it's less kind of stringent than the way that the Java folks approach it, but it achieves some of the same ends, which is that we get some miles on the feature before we commit to exactly what it looks like. And there are people out there who are willing to take the risk of starting to use it a little early. It's kind of a different version of that. It's the same kind of, the runway is up to a year, so it's the same order of magnitude. We're just, kind of more loosey-goosey about it. We put the feature out when we think it's probably done, or when we think now would be a good time to get feedback to help us make the last decisions. And then by the time the release comes around, then the features are either in or they've been yanked.
Yeah.
And usually they're in, because it's rare that we put something in preview and yank it. Like, that is the exception. We usually feel like we know this is going to be good. We're sharing it either because we need to polish it with some feedback, or just because it's done and you might as well get it.
Yeah, makes sense. So I wanna move a bit beyond C# 11 and talk about C#'s future. And there's many ways I can start this, but I want to start with the biggest criticism that people have with C#, because I'm sure many people would like to know. Do you think that C# is becoming more like, or it's adopting C++'s problem of being bloated or becoming too large? And have you considered ways to combat it with maybe how Rust, from what I think, has versions where something is in now, but in the next version it's not? How do you feel about that?
It's something that's very much on our minds, because essentially, the way we're going about it and the way most programming languages go about it, once you put something in, you can't take it out. It's back to the back compat thing. Even if we did turn the dial a little bit on the back compat, I mean, it wouldn't be to the point of starting to yank features out. I don't think that's a thing. I mean, from where I stand, I can't see us doing that anytime soon. That's the foreseeable future. That something else would need to change pretty dramatically for us to do that. So we're not going to remove features, which means C#, understood as the language that the compiler compiles, gets only bigger and bigger. And there are various ways that we already try to mitigate the effects of that, and that we could do more to mitigate the effects that we're talking about. For what we already do, it's this is a central aspect of language design, is how can we, first of all, let's not add the feature unless we think it's worth the complication cost to the language. And secondly, because we do add a lot of features, we are leaning in on that. Try to add it with the minimum conceptual and syntactic overhead. Try to make it as general as possible. Try to make it fit as well as possible with the existing features, as orthogonal to them as possible, and so on. So to try to keep some of the unity of the language. Sometimes we're even lucky that a feature removes a special case, and actually makes the language simpler conceptually by not having when something sometimes works and sometimes doesn't. So, but that's a lucky day, but it happens. There's still a lot of C#, and there's a lot of it that people probably shouldn't use in their day-to-day, right? There's the reason we add features is that we think they're a better way of doing that thing than what you did before. And so what you did before, ideally people should stop doing that.
Yeah.
But we're also not going to remove it because, hey, you want to keep compiling code and not, you don't want to have to go back and fix up all your code to make us happy for some purest thing. If it's working and it's fine, we should keep compiling it. So if we want to do something like a soft deprecation, if you will, of some of the language features in C#, we have to do it extremely softly. We have to essentially make it more of a set of recommendations, like maybe a recommended subset of C# that is like, we've been talking about it as, and we're starting to work on it from a documentation point of view as everyday C#. If you were coming to C# and trying to find out how to do different things, what's a set of C# subset of C# you should be considering today? And then ideally in the future, we sort of do this a little bit, but not in a systematic way. We would, with tooling and everything, with documentation, we would guide you to that subset of C#. That would be where that would be the pit of success that we would point you to from all levels of tooling and so on, without being judgmental. If you like something different, and without like giving you an unnecessary trouble for things that you just don't want to touch again. So we're kind of looking at ways that we can have the recommended, very, very soft ways. We can have the recommended C# of today. And then whether something is kind of outdated or whether it's advanced and most people shouldn't go there, there will sort of be things that you can pull in if you need to. Like if you think about an example of the advanced stuff is unsafe code, for instance, and all the ref stuff, that ref structs and so on, that are essentially the modern replacement of of unsafe in C#. That's most of that is probably something that most people don't need. But if you need high performance, you want to tinker closer to the metal. Yeah, then in the old days we would say turn on unsafe and go to town with your pointers and suffer the consequences. And nowadays we would say, okay, now you maybe use even ref structs here, or use it spans and refs and whatnot. And yes, your code gets more complicated. Only spans, yes. You have to be able to at least understand the lifetime related error messages you start getting, saying, hey, you're letting something escape that won't be around when when somebody else gets to it, and that kind of thing. But it's optional and it's outside of the everyday C#. So that's another way that we're starting to try to help people to the C# that's good for them without being judgmental or heavy-handed about it.
Have you considered, and maybe if someone is watching this even live or later, and they want to do something like that, they can. But have you considered using Roslyn analyzers to analyze someone's code and say, the starter C# or the modern C#, and by default you warn on what is outdated maybe features, and you can suggest a refactoring on how to update it, and then people can turn them into errors if they want, and they can choose version that way. So you don't really touch the language, you just use a Roslyn analyzer.
That's exactly the kind of thing we're thinking about.
Okay.
Yeah. And so I think that is very likely next step for us to take when we feel that we have to be very careful with these things, because how people write C# isn't really our business, except we want to help, right? So we really have to be really careful. But once we've identified this, and it's going to be a moving target, right? Every time we add new features, some others are going to drop off. Once we have identified sort of, this is what we'll call everyday C#, this is what we'll stay within inside of docs, this is what we'll recommend for teaching curriculum, so on. Then another thing would be, oh, and here's an analyzer that helps you stay within that and helps you get there if you're not there, if you want to. And there'll be a whole lot of concrete design questions about how can we make that analyzer customizable enough that it's not obnoxious to you and that it helps you with just the parts that you want help with. But that is definitely that is sort of that's a good avenue for the toolability of the everyday C# concept, if you want.
That's fantastic. That's awesome to hear that actually you might look into that as well. Because as someone who has worked with graduate and junior developers and is teaching C# as well, saying, oh, that's no longer the best way to do this. This is the best way. And then someone links me a Microsoft doc from 2011, I don't know. And I have to explain, no, that's outdated. That's a different thing. There's some friction you don't want to have there. Now, I want to touch on something very interesting that I've noticed, especially in the past few C# releases, because I think as an observer, I see C# touching three main core pillars. I don't know if those are intentional or unintentional, but that's how I see it as an external viewer, which is you're really doing three things: improving performance, you are turning functional, or you're adding more functional features, and you are adding quality of life improvements. For example, quality of life is the generic attributes. No longer do I have to pass a type of, now I can just do this, and so on. We saw list patterns expanding on the pattern matching aspect, which is fundamentally more of a functional concept. And obviously performance, I've read the whole Stephen Tobe blog, and that's also .NET. It's not just C#, but there are things you're adding on C# for performance as well. Are they intentional? And do you think I'm missing anything that you're also focusing on? What do you think about that? Because the functional aspect is undeniable, and I'm very interested in that, coming from an object-oriented programming language, which is C#.
Yeah, I think you're hitting most of the things, but I will say that it's not actually you might not believe this. I mean, I'm even sometimes giving a talk that outlines all the functional things we've done in C# since it started. But being more functional is not a goal for us. It really isn't. Having better expressiveness in the world that we are coding in, which is an ever-changing factor as well, is important for us. And it turns out that functional programming has many answers for a cloud-based world, for instance, that we just look and say, you know what? Functional was on the right side of history here, and object-oriented programming wasn't. The simple example, with a cloud-based world is that object-oriented programming rolls data and functionality together. Class, that's the essence of a class. State and functionality are together. They're designed together. They belong together. And that's just not how most data is. Once data starts transcending the individual application, functionality to some degree starts transcending the individual application, but not together, right? There's the description and layout of the data is one thing, and then there are various pieces of functionality over that data that can be reused, whether through Azure Functions or other ways like that are used across multiple different services, right? Services of functionality as well, sometimes actually wrapped with data and sometimes not. And so being able to do a good job in the face and have good intuitive readable code in the face of that necessary separation between data and functionality, that's something functional programming is really good at. And we steal those concepts liberally and have done for a long time so that we can be a modern language in a cloud-based world and give people the abstractions that actually do the right thing for them in those situations.
Okay.
But if something came from not everything we do comes from functional, though a lot of it. If another paradigm had the right thing to offer, we would steal that too. It just so happens that there's a prevalence of functional things. If you look at async is a counterexample, for instance. I know async is getting a bit dated, but it's one of our biggest, if not the biggest, cloud feature in C# ever. It's a thing that enabled you to live with latency naturally, okay? And async was already a thing in F#. It was very functional. You construct a whole flow of things, and then you pull the lever, and then data starts flowing through the pre-built network of things. And in C# we very deliberately chose a very imperative approach, which blends much better with the C# that was already there, which is that async is something that you have things that run, and you combine the running side effecting mutating things through a wait. That's the things that you are cobbling together to create your flow of data and functionality are hot. They're spinning and they're doing things. They're side effecting. They're imperative. And that was a very deliberate choice. So it's not that we always do the functional thing, but very often it has really good answers. And very often those answers need to be adjusted or modified quite a bit before they fit into the fabric of C#. But you can definitely still look at them and see the functional origins, and we're fine with that. That is, things like pattern matching are key feature now in C# to deal with that separation of functionality and data. They definitely look functional, but the patterns we have are very, they're fitted to be useful with C#.
Some of the biggest criticism against pattern matching, from what I've seen, is being able to use variables in the patterns. If I remember correctly now, for example, if you have a list pattern, you have to say that it is within 1, comma, dot, dot, underscore, discard the middle, and then something in the end. And the main criticism is it's not as flexible as people would like them to be. Is that a constraint or a choice you've made to not have that be possible, just so you can get the feature through the door and maybe expand on it in the future, or it is just a limitation on implementing it?
I think we're definitely not done with pattern matching yet. It's one of those. It's not really a feature so much as a feature set. It's patterns are like statements. We can always add a new kind of statement. We can always add a new kind of pattern. We can always generalize the ones we have. And we are eager to do so. We're sort of driven by, what is the next important scenario again? Like what is the next thing? And we're very deliberately being incremental about it. Again, so that we design things to actual concrete scenarios. There are some limitations that come from, we're very ambitious about the compiler analysis around pattern matching, particular in switch expressions, where we want to be able to tell you if an earlier pattern subsumes a later pattern, and we want to be able to tell you if the switch is not exhaustive, if there are things that can fall through. It's allowed. You get an exception if it happens, but of course we want to warn you about it. So whatever we do needs to be able to fit into that analysis. We need to figure out how do we fit it into that decision tree analysis that we do in the compiler, which is getting fairly complex. We use that both to do that analysis and actually also to try to do the most optimal code generation. So as long as we can do that, or as long as, at least we can carve out an exception and not topple the value of the whole thing, then I think we're open to doing many things. So the specific thing, I'm not sure the specific thing you're asking about with the variables. There's definitely there's a situation right now that if you have a disjunctive pattern, you're like, it's either this or that. We don't let you use the same variable in both branches.
Yeah.
Even though, so that gets awkward. Like either this provides the result or that provides the result. The results are the same type. Why can't I just use the same name? And that's a feature we're actively working on. I'm not sure it's going to make it into C# 12, but it is a feature. There's a lot of design details in it as to, how far out can a variable be shared between two places it gets introduced in patterns. But, that's something that it's not a fundamental limitation. It just needs to be a design that is reasonable and makes sense in a C# context. So we can fix that.
Okay, awesome. That's great to hear. Chat is going crazy with one specific feature, which I don't know if you're looking at chat or if you, but
no, I'm not on that side of the.
Everyone is asking, Mads, discriminated unions, and I've heard one of the answers you give in another podcast, but I'm very curious to, and of course I'm going to ask you, are we going to get them, and why didn't we get them already?
So I can answer the second one.
Okay.
Which to start with, which is there are many takes on what discriminated unions are and what they're for. Okay? And we are eager to provide the value that discriminated unions provide. And there are some places where we don't today. There are also, and when we say discriminated unions, that's one thing, but there's also other kinds of unions out there, and they also provide value. If you look at TypeScript, they don't have discriminated unions. They just have unions. But they also have a structural type system. And by the way, it gets erased at runtime and so on. So they have a very different situation, but their unions are very powerful from an expressive point of view. And so we want to holistically do the right thing in this whole space. Whether that ends up being in the form of something that looks very much like discriminated unions in functional languages, or whether it ends up being something different, that's a very open question. We are actively debating it. We have several people off in a working group right now examining the different angles on it. So some of the things that people are looking for with discriminated unions that I'm very wary of are as an alternative as a complete alternative to inheritance for building your data model. If we're talking like syntactic sugar or something like that, fine, we can talk about it. But if there's like these two fundamentally different ways of describing the sort of the shape of your data, then that's not a good place for C# to be. Then it loses its sort of core focus, if you will. Then becomes two languages in one. Like, are you a discriminated union programmer, or are you a class hierarchy programmer? That's not a good place to be.
It clashes with inheritance fundamentally, the way it's mostly described, right?
Yes, but in some cases, like in Scala, for instance, they went out of the way from the start to insist that these aren't different things. They're different syntaxes, or kind of, they're the same thing in different guises, if you will.
Yeah.
Which means that they interoperate super well, right? There's a shared core feature underneath, and I would much rather get to that kind of place where you like a bit more like records, which are really classes or structs as well, right? They're not a separate thing in C#. It's that kind of design I would love, where yes, I can more concisely express my data model. Okay, that's one value that people talk about for discriminated unions. Well, why shouldn't you be able to more concisely describe your class hierarchy? You know, why isn't that just something that why don't we just make it nicer? Or I want exhaustiveness. I want to be able to know that there aren't any more classes I hadn't heard about because some other library implemented another derived class. Okay, exhaustiveness. Well, that's a feature we could talk about. By the way, that actually Scala does that, right? They have case classes, which just is a way of saying, well, I'm one of the only classes that can derive from this other thing, or and there's a limited place where the classes can be declared and they can't be anywhere else. So you can get exhaustiveness in your pattern matching. So fine. That's another value. We could provide that without having discriminated unions. Then there's stuff like, which we see, which is prevalent, for instance, in ASP.NET scenarios, where you have, it's very common that you want to return, like you're dealing with some HTTP request or whatever, and your result is either a successful result or it's some error. So essentially you have a union of two types.
Yeah.
You don't want to throw in, you're not throwing an exception. You're saying the result is either a value of this type, or it's like an error message of this type, or something like that. Classic union territory. However, if you're not careful, then even if we had a union feature, the wrapping of the value and the error message inside of the body of that handler would be obnoxious, right? You have to say result dot as blah, 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 something. That's kind of where they're at today. That's what the best they can do with what we give them. So there it would be kind of nice to have a sort of anonymous union saying, you know, just here I return this, here I return that. Instead of the compiler saying, I can't figure out the return type of this lambda, why don't we just, you know, could we just say, I can figure out the return type of this lambda, and it is a union, you know? But that's a scenario that discriminated unions don't necessarily handle very well either. So lots of things in the mix, and we're still navigating what to do or what to do first. You know, it might be a trickle out. It might be, okay, let's add an exhaustiveness feature. And by the way, now we're added to enums as well. you know, and the next thing and next thing. So we'll see. But we are not kicking the can down the road anymore. We are very actively investigating and unpacking these scenarios and comparing approaches. So I think something will eventually happen. Will it look like discriminated unions? I can't promise that, because as I told you before, we're not wedded to pulling all things functional into C#.
Yeah. Okay. That's for those of you in the chat, by the way, who's still wondering, we're not gonna see that in C# 12, maybe not even in C# 13, from what I understand, right?
Probably not. I mean, technically, if we had more confidence that we were on the right path, then something like exhaustiveness is a small feature. We could do that easily within that time frame. But the trouble here is looking at it holistically and feeling good about the first step we take, not blocking off what we would eventually have liked to do.
Yeah, I see. I think the most common use case that I've seen when it comes to the need of unions is, I have a method. Let's say it creates a user. So I have an email, a username, a date of birth, and a bunch of other stuff. What people usually do, and now they use libraries like OneOf, which tries to provide similar experience, is you can get the created user, or you can get a user email already exists type, which has all its own properties and so on. So you have like 4 different types that you can return, and then you have exhaustive matching on those 4 or 5 types, or 2 types as well. And then you guarantee that all of them are handled in some way. That is the bare minimum, I think, that most people would want to see from a feature.
Yeah, and that is something we could quite likely get to without having full discriminated unions.
That's I really hope that feature makes it early in a preview, if it ever makes it into the candidates for the next C# version, to get all the feedback it needs.
Yeah, and I could imagine that kind of feature, that where so many people have so many opinions. It could conceivably be a feature that we add in preview, and then keep in preview, even across multiple releases until we're sure we get it right. And we just have to be so darn careful about not, on the one hand, we have to be courageous and do things and not be stymied and never take the first step. And I think we've proven that we are not generally stymied. We do lots of things, but also have to be careful of not flying blind. Oh, they want discriminated unions, let's give them something. It has to be, with these kinds of things, these are big areas to push into. It was the same with pattern matching. We had to be really, really judicious, and we thought about it for years before we even took the first step, because we want to make sure that, as much as we can, that the path forward from the first step is the best possible one that we could take.
I see. So I wanna ask you, if you could, just on a fully personal level, disregarding everyone, if you could add a feature in C#, ignore breaking change, ignore everything. Obviously, you're a language designer, you're looking around a lot, you have your own ideas as well. What is one feature you'd love to add in C# on a purely personal level?
On a purely personal level, I think most of there are definitely features that I wish we could add, but that C# doesn't lend itself to. There's stuff like that where, just as a language designer, there's we went down this path, that is great. That other path could have been fun too, or that maybe it would have had to been a completely different language. I feel like the world is still short on languages that deal super elegantly and inherently and intuitively with concurrency. It still after all these years, it still feels like a bolt-on kind of thing. We're sequential first, and most languages stop there and leave anything concurrent actually even to libraries. And C# has some somewhat concurrency-related features like async, which essentially is there to deal with the fact that there's more than one thread of execution in the world, but we don't have elegance there, and we still don't really. I don't think we have together as like a programming language community. We haven't identified the abstractions that make people feel that they're confident and writing elegantly in the face of concurrency and distribution to some degree too, right? There's some languages that are all about that, and they have a take on it. So if there are Erlang programmers out there listening now, they'll be like, "You're wrong. You know, this works." And yes, you're right. There are definitely takes on it, but they're not really universally or near universally adopted and agreed upon. And many people do not find them intuitive at all. Many people think that, you know, as soon as you get into like actor-based or something like that, yes, it deals with some things, but now you're restricted in other ways, right? Your state is protected by a sequential kind of mailbox handler thing or whatever. None of these models really kind of hit a sweet spot of, yeah, get concurrent is kind of handled, you know?
Yeah.
So I know I don't think this actually even answers any part of your question, but it's a problem area that, you know, in a parallel universe, there's a Mads somewhere off noodling with that, and because I think it is. I love kind of the more academic side of me, or, you know, loves kind of the search for the deep underlying abstractions that take gnarly things and make them clear. And you know, the kinds of things that are the kinds of inventions that are many of in computer science and elsewhere, where they are impossible to imagine until you get them, and then they're simple in hindsight, right? You know, the cat flap kind of things.
Yeah.
Yeah, we need that, and we don't have it, and I would love it.
Since we're here, what do you think? Obviously, F# had the concept of async, which was based on Haskell anyway, and then C# implemented that with the state machine and await async, and then it was adopted into other languages, JavaScript, TypeScript, and so on. And now it's so viral, it's everywhere. But the other approach we see in big languages is Kotlin's and Go's coroutines and Go routines, respectively. What do you think about that model of implementing asynchrony?
I actually really like it in many ways. I think that async, we considered coroutines when we ended up doing async. They're like coroutines are a concept that has been around for now probably half a century. And they're elegant in many ways. So what ended up becoming async was the result of many years of wandering in the desert and looking at different approaches. And coroutines was one of the ones that we looked at. We ran into a couple of things that made us not go that route. One of them was it was very hard to retrofit. Another one was that, what do people really build with coroutines as a core like functionality? Well, they essentially, at least the landscape that we could scour at the time, they essentially built iterators, which we already had as a specialized language feature at the time. They built async, and then they built async iterators. So it's like, that's all the scenarios covered. So if we wanted to abstract over all of those, we should have done it before we added iterators. Essentially, we were like, we might as well do another specialized feature for async rather than coroutines at this point, because now we can have syntax that is more intuitive to the concrete scenarios in place. Instead of, like, we don't have something like F# workflows where you can sort of almost define your own syntax for a bunch of different scenarios. And the cost of abstraction in terms of just what the syntax would look like, what code would have to look like every time you do something async, felt like it would be too big for an abstraction that we would never really reach for again. Like, it'd be like, we're done now. We've got async. We're done now. So that's why we ended up saying, let's do something more concrete that has the word async in it and the word await, and that'll help transition people into this and feel comfortable about it. Now, that's over a decade ago, and we're probably at a point where it's getting a little long in the tooth, both in terms of the abstraction itself, but also in terms of how we, realized it. There are some things that are more heavyweight than you'd probably do today, but it has a lot of good notes to it. I like that we use the future abstraction. They're called tasks, right? And like, there's a lot of good core abstractions in there that make sense to people and make code elegant. Maybe coroutines have found more scenarios that justify them in the meantime, and maybe that's the right way of going. In a sense, coroutines are the underlying abstraction of async.
Yeah. And even in the state machine with the move next, conceptually, I really like the way you can have asynchronous code look like synchronous code and not have to worry about it too much. It makes it easily adoptable. I don't know if you'd have the same approach. Maybe at the time you would. I don't know. It's hindsight 2023 now, and I wasn't using C# at the time, so I don't know. But I can tell you, as someone who came from Java, it was insanely revolutionary to think that I can call the database and that thread can go and do something else, and then it can come back and it's be like, oh, that's completed. I can do some stuff, and my application scales better. Okay, I wanna jump into some. I don't want to say criticism, but in fact, I wanna give you a couple of features and know your thoughts on them very, very quickly. I have my own thoughts on them, but I want to know yours. A feature that has been widely requested I've seen for a long time is async constructors. How do you feel about that?
I don't have any problems with async constructors as a concept. I think we've not really. It's one of those places where you're sort of like, damn, that's just the model for async doesn't really fit constructors very well. So, I mean, we looked at it early on when we did async, or shortly after, and there's no place to sort of put the task of something, there's no return type on a constructor. Maybe we could just have, I don't know, maybe there's a way that it could be done. But from a conceptual point of view, I mean, there's nothing wrong with async constructors, right? It's just a special case of something happening that eventually has a result, and you await it and you get the result. No problem. It's just we couldn't find a good way of fitting it in. It didn't seem like the most important scenario at the time, so we didn't double down on it. I haven't seen or noticed a good proposal for it recently, but if there is one floating around, let's take a look. It might be.
I think it's an old one, like a Stack Overflow post with many upvotes. For those listening, usually you have the need to do that if you're doing initialization in the constructor, but arguably you shouldn't have your initialization in the constructor. The way I at least like to do things is to have a bit of a factory method. So I have a static async method that returns the type of the class I'm instantiating, and then that can instantiate and then do all the initialization in there. And that's the only way you can create objects out of it. So I personally don't see the need for that, but I wanted to see how you feel about it and maybe understand why it was never made.
And I think constructors are a little weird, right? On the one hand, you need they're a special kind of static method in a way, right? You need something at the core of the language where the actual new object gets allocated. But and it explains how what initializers do and how they're what order they're executed in and so on. But constructors are like a special case kind of static function in a way. And abstracting it back out to static factories seems like a good idea. And actually coming all the way back to the static virtual members and interfaces, they give you a way now of, if you want to have abstract factories, like you can't abstract over constructors at all, but factories, you can abstract over factories, right? Yep. Up until now, though, you had to do it by having, factory classes to hold the virtual method that produces the object. You have parallel hierarchies and all kinds of gnarly crap like that. But with static virtuals and interfaces, I expect that one of the more common uses of it, beside the math, will be to have static abstract factories. Yeah. And so many things are pointing towards just using factories more and having constructors. And that's a style that many people use, and it sounds like you do too, of constructors are sort of, they're there at the bottom, but they're not really the way you initialize. You either some combination of factories or object initializers. Well, actually, you can't combine them right now, but either or. We're still thinking about combining those two.
I think the biggest need for the feature, especially from people working with .NET and ASP .NET Core, is sometimes, and I can totally understand that, by the way, sometimes you want to have some initialization on, let's say, a singleton to hold some state, and that state requires an async call to be instantiated. But if you do add singleton in the DI container, there is no way to have a sync there. Like if you put a sync, you just made an action, and that causes it to be an event, and that's not really a sync, and then you're into this weird undebuggable loop. So I think that's the real need why people try to do it, because even then, you cannot have an async factory in DI that way. You have to... There is a proposal, I think, in .NET to add those async overloads, but that's the only place where I can see it as being useful. The other feature which I've seen, and again, they are not maybe highly requested, but the things I've seen and I'm like, I wonder what Mads thinks about this, is extensions on properties, or property extensions, actually.
Oh, I love them.
And I know we have roles and extensions as a feature, but let me know.
Well, I think that, so we have one of those problems again, like we have with discriminated unions, that we have one shot at getting things right. We know that people in particular, so extension properties are widely requested, like instance properties, just like extension methods. But then another widely requested thing is extension static members. Now you work down the list and you get less of it, but still some extension operators, for instance. I haven't seen extension indexers requested much, but there aren't many indexers in the world anyway. But so there's a sort of like a clear desire for what we've been calling extension everything. Why don't we just generalize extension? Yeah. Again, this is the release after we added extension methods in C#3. In C#4, we were very far down the path of one approach to extension everything. And thank God we didn't do it, because it was so the wrong thing. And we realized along the way, and we didn't do it. But we're looking at it again. And there's just one of the reasons we haven't gone here for a long time is that essentially extension methods are in this syntactic dead end, where the way that you declare one doesn't generalize to other kinds of members. Because it has this parameter. Well, guess what? Properties don't have parameters when you put this parameter. Yeah. And so on. So there's and then there's also a certain, there are ways that the seams start to show when you do it that way, when you translate it away, where there are ways in which it'd be nice that they're more first class, We also have the role scenarios that combine very well with extension scenarios. So if we want to do both, then we have to be, coordinated about it. And finally, then there's the sort of Haskell type classes, pie in the sky potential end goal of allowing extension interfaces. And that will certainly require runtime participation of some sort, where you could essentially say, well, I have this interface over here. I want to say that int64 implements that interface, but I can't touch int64. But just for my purposes here, extension interface, here's how it does it, go figure. And that is perhaps like a lofty end goal for now, but we need to, again, not take a step down the path that precludes it from happening. So that's part of why this is taking a little time.
I see.
But again, we're working actively on it.
That's interesting. So I like the amount of caution that you have now with introducing SaaS features that can be so viral as well, both with DUs and with extension everything, just as a general comment. But I'm super excited that actively people are looking into that thing. It's, async constructors, I don't care about that. But extension everything, or property extension, that would be good. I can do some really cool stuff with that. I'm gonna go back to I'm gonna go into some more controversial questions.
Sure. You keep saying that, but they keep not being very controversial.
I mean, I want to phrase them in a way that they're not too controversial because it's your first time in the show. How do you feel about events in C#?
I hate them.
Oh, thank you. Okay, they're not controversial because we have the similar views then.
Look, events is one of the I view events as XML literals in C#. They are a particular approach to a problem that has many different approaches that has been encoded into the language instead of staying in the libraries where it belongs. And not only are events themselves, so they're essentially, what's the official name of the design pattern is what's it called? The subject observer pattern or something like that, like the original, Gang of Four design pattern or whatever. Directly, encoded into the language itself. I hate that. But also, it dominated the design of delegates so that they're this Franken feature that is not just a function type, but is also a collection type.
Yep.
So you can add two delegates, and then you get something that has both of them in it. And when you call it, it runs both of them. And you get, if it has a result, you get one of the results, and good luck reasoning about which one. Such an ugly beast of a feature. And at least, we were able to make them generic, and now we could have action and func delegate types up to a certain, arity, and kind of pretend that this is all a little bit structural, like it gets a little closer to proper function types. As long as you don't start like adding them and stuff, and oh my God. On the other hand, we haven't had enough. They're not bad enough that we've been motivated to introduce another kind of function types in C#. They've been good enough for all these years.
Yeah. And
so we haven't really gone and said, okay, now let's really make function types that are maybe truly structural, like that's a type constructor, like generic application, and that maybe is more efficient. Which is something, actually, again, if you ask me, the question from before, privately, what would I like to do? I would like to have proper function types in C#.
Yeah.
But we haven't really gotten to where that is really, we really have have the compiling scenario to do it. But my God, events and delegates, they were not our finest work.
Were you around the time?
No,
As a program manager? No, you're not.
I can freely criticize.
Were you around for Dynamic though? I think you were, right?
I was.
Okay.
I was instrumental in Dynamic. I was a big part of how it ended up the way it ended up. I think I redeemed myself the next release with async, but yeah.
Yeah. I mean, you keep redeeming yourself. Like the amount of value I've received on a personal level, I don't know about everyone else, from the generic math work. Oh my God. The gnarly ways I had to do things beforehand and resort, even with like it solved usage of reflection I had to do in some scenario, like the stuff you can do by just knowing that compile time this thing will be here. It's amazing. And yeah.
I'm really glad to hear that.
It's, yeah, for me, and I'm glad you actually pushed the release, because it was originally supposed to release in C# 10, I think, and then went to 11. And you made some minor changes, if I remember correctly, right? And I don't want to go maybe too in depth for that, because I don't want to talk code without really showing it, and I don't have it prepared, because for the viewers it's awkward. But I highly recommend people look into that feature. I've made videos on it showing other use cases as well. I can guarantee you have use cases about it and you just don't know about it. It's been amazing.
Yeah. Well, I love you saying that, obviously, because it's one of those very expressive features that we pushed out that we truly don't know what people will use them for. Right? It really opens so many doors. We've only imagined a small fraction of them to start out with. So I'm actually very curious what people use it for, especially, of course, outside of math, which like we've been very deeply into that scenario. Very early on, we thought we might have done it in C# 10, but it was actually from fairly early in the C# 10 release, we realized that what we wanted was to have a credible prototype at the time that C# 10 was released with broad adoption. We introduced actually a mechanism we introduced a whole like what do we call it, preview or experimental notion for up and down the .NET stack rather than just the preview flag in the compiler itself, so that we could ship a coordinated prototype at release time and get a lot of people to use it. And as a result of the feedback we got on all that, we made significant changes. The core idea stayed the same, but we added a number of things, changed a number of things. And by the time it really shipped in C# 11, we had very high confidence in it.
That's fantastic. The thing is, what I really liked about C#, again, coming from Java background, is how, I don't know how to explain it other than how cool it is and how much I can express myself using C#, especially in way less code and more elegant code compared to needing to have a getter and setter every time, and or having a wait async. So yeah,
well, if you're trying to rile me up with controversial things, you have to do better than this.
The thing is, I said I hate events, and you said you hate events. Chat said I love events. What's wrong with events? So chat found that spicy, but I didn't, because I just didn't like them. But I have to take the feedback from everyone and ask questions that I think people would also want to hear an answer to. Those are topics I have made videos on, and advocating against those features. And because that's how I feel, and I ultimately express my opinion based on what I've seen. So having you say that adds a bit of credibility. But yeah,
you're gonna just play that little clip.
I'm gonna cut a short video and I'm gonna upload on YouTube and say, by the way, in case you're wondering, go tell that to Mads. Do I want to go there? I guess I'll go there. So we're talking about different languages and Lang and C# and Java and Kotlin and a few things, and obviously you're in a very unique position. You're the lead language designer of one of the most popular languages in the world. I think it ranks as 5 now in the new index of all languages, or 6, I can't remember, and it's increasing. So languages are one of those things that people just use and get very radical about, and rally behind it and try to get everyone to use the thing that they like. And you are someone who has studied religion and you were intrigued by the human condition, from what I understand. So what do you think people get so passionate about programming languages and sort of try to, in very similar with a religion parallel, try to get people to convert or change to use the language that they think they like, or that they like?
That's a great question. I don't purport to have the answer to it. There are probably even religions about that too. But but I think that, I mean, a language and a religion, they definitely have some things in common, that they provide a framework for you to think in that can seem, uncomfortable or counterintuitive or unapproachable to start with. But if you get in there, when it clicks, when your worldview aligns, when you are comfortable navigating there, it's like spoken language as well, right? Natural language. It is obviously right. And it can be hard to dissociate yourself from the personal emotion of obviously right, and view that and realize and act in according to the realization that that's right for you. But you can't just transfer the epiphany, not by persuasion, and certainly not by yelling the loudest, right? It just doesn't happen that way. So that's one thing. It's sort of just the cognitive click that feels universal, but really, I'm sorry, but it's specific to you. You're having that, you're feeling at home in C#, great. You can't just go and say C# is a language that you will feel at home in. They might not. Many people apparently end up doing it. So good. But so it's a broad religion, if you will, but not, other languages are great too, and you can feel at home in them too, even if they're radically different in many ways. It's just a matter of getting into the manner of thought, or the structure that it imposes on your thinking, and getting to it feels comfortable. Many people struggle with working with more than one programming language at a time, especially if they're radically different. It's hard to switch between them. I remember when Anders was between C# and TypeScript, and he would come to the design meetings and he would start writing the wrong syntax on the blackboard or the whiteboard or whatever we had back then. It's just hard, right? And it's same for religions, obviously. Very few people have more than one.
Yeah.
Because it tends to be hard to reconcile with more than one. So I get that. And another aspect of it is social. It's that you get into a community that shares that same worldview. They reinforce each other. They help each other out. They deepen each other's commitment and understanding. Same for religions, right? They're very community-based. Very few people are religious on their own. For most people, it's a big part of the community aspect is a big part of it, even sometimes to the point of not necessarily thinking about what would you want, but bending to the trends of the community. That happens in both kinds of settings as well. So there are many parallels. Personally, I didn't study a religion. I studied religions. And I like programming languages, plural. And while I need to be deeply absorbed into C# in order to help design it, I also need to step outside of it because the things I'm making aren't in there yet. And so I need to look at the rest of the world as well. And I enjoy the multitude and diversity of programming languages out there. And I enjoy the fact that there's not one right way. So I'm actually not very religious about C#. I try to make it the best C# it can be.
Yeah.
You know, and I am perfectly happy, and I'm actually, it fills me with joy that there are so many other takes on things out there. It's not a competition, it's too, but not primarily a competition. It is, we're all trying to kind of move the world forward to greater expressiveness and higher levels of abstraction, that kind of thing.
Yeah, to me, what is interesting is obviously everything you said, but also the fact that it's a bit of a catch-22 with languages, where it's like the more people use a language, the more people will use a language because they see, oh, there's an audience here. And the less people use a language, then the more people are likely to ditch a language for another one. And the ones who stay back, it's the ones where the vocal minority will say, oh, just this thing is what you want, come here, let me show you. And that's not how you get people on your side, really. It has to be a natural thing, in my opinion, where you find that this language is what you need. And I can only imagine, but I also would like to ask, obviously as a language designer, you have to see what other languages are doing. I would find that very interesting, and I'm doing that to see where C# is getting inspired from. And obviously outside of F#, which other languages are you personally looking at for the paradigms they implement, and you say, oh, they did that, that's nice, we're gonna bring that over, or maybe in some way implement it?
Well, in principle, all of them. You know, F# is one, I think, the coolest around, but one representative of a functional tradition. There are many. So even there's like a multitude of different things. The one I want to call out there also is Haskell, which has had much more influence on other languages than as its own programming language, even though it is, you know, a healthily adopted programming language in its own right. So I like languages that, or I look at languages that are likely to have, you know, new ideas as well, like new concepts. I mentioned Scala a few times. I'm not a particular fan of Scala as a language of programming. I mean, there are some, you know, design tenets where I think they go overboard in implicitness, for instance, and it becomes too hard to see what the program is doing, though people accuse the C# of going in that direction too. But the way that it started out with some deep soul searching and some deep insights that essentially paved the way for the rest of us to bring functional and object-oriented together. That's been deeply inspiring for decades now. Obviously, I had my time in Java. There's lots of good stuff happening in Java again, and has been for a while. The people working on it are super smart and serious and diligent, and I've had many great conversations with them over the years. I had a few more I wanted to mention. Actually, Swift has been interesting. Again, in some ways they land in different places and they had different design constraints, like coming as a new skin over something that was optimized for Objective-C. They had to make some choices around, you know, reference counting and so on. We're kind of limiting in the design in various ways, but they've done a lot with that, and have been willing to think out of the box in many ways. It turned into a beautiful language. Kotlin has a focus on ergonomics, not necessarily keyboard ergonomics, but brain ergonomics, that things they strive for things looking very straightforward and very readable without being without being too long-winded. I could keep going. It's just there was a time when Java looked like it was going to rule the world. It was going to be the one language that everybody learned in school. And luckily now we're in a time where there are many things to choose from and many different mindsets and so on. Oh, Python. Oh my God, Python. Beautiful little language that I get. Guido is Guido is my colleague now. I get to talk to him.
I do.
I meet with him every month. That's like amazing. C++, people love dissing C++. When I was a tiny little undergraduate student, people were already dissing C++ for different reasons than today. And yet still here it is, having all kinds of innovation going on in it. And really, like, I want to say tongue in cheek that they're showing the way for the rest of us in terms of the art of fitting more things in without breaking other things.
I want to say, unironically, I've recently, like a couple of months ago, because I had no, my vision of C# was very, C++ was very archaic, like from back in uni actually, which is, 10 years ago now. I'm thinking about it. I'm getting old. What I see now and the features they're adding and the way they're adding them, it's very interesting to the point where I actually want to try it. It's like you said, it's a masterclass on adding features in an already what is considered a bloated language without making it too awkward. And maybe a lesson other languages can learn from.
Yeah, so I just I love all the art and handiwork going on out there and all the creative thinking. And luckily, I get to work on a language where the philosophy from the get-go, that the tone that was set by Anders on day one was, we are not going to be shy about innovating. We're not going to do the thing that Java did in the beginning, saying there should be only one way of saying things, and once there's a way, we stop. Or that a language like Go has been clinging to for too long. Being in a language that has as one of its core tenets, like we published our language strategy at some point, it's a core tenet for us that we will keep evolving, we will keep making things better. And getting to do that is a dream job for me.
Yeah. Well, I'm looking at the time and I know you have to go in 5 minutes. So I'm going to just quickly wrap this up to give you a few minutes before your next meeting. But Mads, thank you so much for being here, answering all these questions. I remember myself when I started with C#, I was listening to things like the .NET Rocks podcast, and one of your episodes at the time, I don't know if it was C# 7 or 8, but it was one of the first ones I listened, and another podcast as well. And the way you communicate where the language is going and being able to have you now here is huge for me. So thank you so much for being here. I really appreciate it.
Well, I appreciate the chance, and I really appreciate these were deep, fun questions. This has been a super entertaining and mind-boggling 2 hours for me as well. So thank you so much.
Awesome. Well, have a good rest of your day. I think it's like 11 where you are now, so have fun.
I will do my part.
Bye.
Cool. See you all.